Hi there, hope you have a fantastic day today. This lesson I will teach you normal distributions. Of course, there is a PDF file version on the description below for you to download so you can work with me. Otherwise, let's go straight into it. For normal distributions, so the curve is symmetrical about the mean. So this means that on this side here is 50% of the data, and 50% of the data is on this side, because it is symmetrical about the mean. And we know that there are about 68% of the data within one standard deviations from the mean. So since it is symmetrical, so we know that from here to here, and if we use 68%, we divide by 2. So 68 divided by 2 is 34. So this side here is 34%, if you like. And this side here is also 34%. So if we add together, will give us 68%. Okay, so please keep this in mind for me. We also know that there are about 95% of the data within two standard deviations from the mean. Okay, please remember this for me. We also know that there are about 99.7% of the data within three standard deviations from the mean. And since it is 100%, so therefore we can work out the percentage of these two here. So altogether is 100%. So if we go 100%, we minus 99.7%. So that will give me 0.3%. But then we can work out just one of these because they are symmetrical. So we just go 0.3 divided by 2. So that will give me 0.15%. So that is 0.15% here. And of course, this is 0.15%. So please keep that in mind for me. So let's just go through one example. So for a mathematics test out of 45, the standard deviation is 4. So let me just write this down. So the standard deviation is 4. And the mean is 27. So mean is 27. If the marks are normally distributed by the percentage of the students that score between 23 and 31. So step number 1, we need to draw a normal distribution curve first. So let me just quickly just draw one, and the mean is 27. That is the mean. So therefore, 23 is on the left of the mean. So we go 27 minus 4. So that is one standard deviations. So that gives me 23. So that means 23 is one standard deviations below the mean. So let me just write 23 here. And for 31, so 27, if we plus 4, that would give me 31. So therefore, one standard deviations above the mean. So this is 31. So we know that within one standard deviations from the mean, so the percentage is about 68%. So the answer is, so therefore, 68% of the students that score between 23 and 31. That's how you do it, okay? So let's go through part B. So just a quick sketch, okay? So we want between 19 and 27. So we know that 27 is the mean. And then 19, so to work out how many standard deviations is below the mean, so we just go 27 minus 19. So 20 minus 19 is 1, at 7, give me 8. Otherwise, use calculator. So this means that 19 is 2 standard deviations below the mean. So 19 here. So this is what we're after. But we know that they are symmetrical. So 2 standard deviations from the mean will give me 95%. But we know that they are symmetrical. So therefore, so between 19 and 27, which is go 95 divided by 2. So that will give me 47.5%. So therefore, 47.5% of the students that are scored between 19 and 27. Okay. Part C. So between 31 and 35. So let me just draw a curve first. So this is 27. So 31 and 35. So 31 minus 27 is 4. So that is 1 standard deviations above the average, okay, above the mean. And then 35. So we just go 35 minus 27. So 30 minus 27 is 3. Add 5 is 8. So that means 2 standard deviations above the mean. So this is 35. And we know that they are symmetrical, of course. So from here to here, within 2 standard deviations from the mean. So this is 95%. But what we're after is between 31 and 35. So 31 and 35 is here. This is what we're after. And we know that between 1 standard deviations from the mean is 68%. So therefore, to work it out, we just go 95% minus 68%. So just go 95 minus 68. So that is 27%. So if I do that, it will give me this side as well, of course. So therefore, I have to divide by 2. So that will give me only one side. So I just go 27%. I divided by 2. So that will give me. So I just go answer divided by 2. So that is 13.5%. So therefore, 13.5%. So there you go. Part D, greater than 35. So again, just draw a bell curve. So this is the mean, which is 27. If you like, I can also write 27. And then 35. So if we go 35 minus 27, so that give me 8, remember? So that give me 2 standard deviations above the average or above the mean. This is what we're after. So 2 standard deviations from the mean is 95%. So what that means is 100% with minus 95 will give me 5% for this side here as well. So I must divide by 2 because we're only after the top end. So I just go 100% minus 95%. And then we divide by 2. So that will give me 100 minus 95 is 5. Divided by 2 is 2.5. So there you go. So therefore, 2.5%. So there you go. Please pause the video and try this one yourself. Hi there, I'm back. How do you go? So let me go through it with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into this. So we know that the mean is 168 centimeters. So let me just note this down. The mean is 168 centimeters. And the standard deviations is 5 centimeters. And the question is asking for between 158 centimeters and 178 centimeters. So let me just quickly draw a bell curve first. So that is the mean, which is 168. And 158, so that is 2 standard deviations below the mean. Because if you go 168 minus 158 is 10. So that means 2 standard deviations because 1 standard deviation is 5. So 2 standard deviation is 10. So we go 2 standard deviations. So 1, 5, 8. So there you go. And then 178, which means 2 standard deviations because you add 10 from 168, that give me 178. So 178. So therefore, between this, which is 2 standard deviations within the mean, So therefore 95%. So therefore the answer is 95%. So there you go. Part B. So again, let's just draw a curve first. So the mean is 168. So therefore, we just go 168, we minus 153. So that give me 15. So this means that each standard deviation is 5. So therefore, 15 is 3 lots of 5. So this means that 1, 2, 3. And 173, so we just go 173 minus 168. So that will give me, so I just go 173 minus 168. So that give me 5. So that is just one standard deviation above the mean. So this is 1 here. So we know that from here to here is 68%. And then from here to here symmetrical. And from here to here is 3 standard deviations from the mean. So that is 99.7%. And what we're after is this area here. Now to work it out, so first of all, so we just go 99.7% and we minus 68%. So if I do that, it will give me this area and this area, okay? But we just need to work out 1, so we just divide by 2. So I just divide this by 2. That will give me, so I just go fractions 99.7 minus 68. And then we divide by 2. So that will give me 15.85%. So that is just one of these, okay? So 15.85%. So therefore, the shaded area that is between 153 and 173. So we just go 68% plus 15.85%. Because this area here is 68% and this here is 15.85%. So we just add them together. So that will give me, so we just go answer plus 68. So 83.85. So there you go. Last one. So less than 178 centimeters. So let me just draw a curve first, okay? So this is the mean, that is 168 centimeters. And 178 centimeters, so if we go 178 centimeters, we minus 168 centimeters, that give me 10 centimeters. So that means 2 standard deviations above the mean. So 1, 2. So 178. And we want less than that, okay? So this means that we need to work out this area. But then we know that within 2 standard deviations, so 1, 2 from the mean, so this from here to here is actually 95%. So we can actually work out this area and this area. Of course, that's symmetrical. So we know that altogether is 100%. So we go 100%, we minus 95%. So that give me 5%. So that is for this and this together. But we only need to work out one of them. So we divide by 2. So 5 divided by 2. So 5%, we divide this by 2. That give me 2.5%. So therefore, to work out this area here, if you like, so we just go 95%, we add 2.5%. So that will give me 97.5%. So therefore 97.5%. So there you go. I hope you got all of them correct, and thank you so much for watching. Bye.